Now it states, I'm going to speak about this in a couple as well. It states dropping unknown layer 4 session from router 2 to router 1 on zone pair ZP internet class default due to drop action found in policy map or IP and whatever. Let's see if I can ping at the SVTI level. Let's see if I can ping router 1 at the tunnel level. And it doesn't work. This is going to be ESP traffic. So the control plane of the tunnel went up. The SVTI tunnel is up and running. But now as I'm sending traffic through that VTI tunnel, it's going to be ESP traffic destined to the router itself, which is likely going to be dropped. So I have to build another class map on router 1 of type inspect class map of type inspect, name it CMap ESP, match protocol. I'm not sure if it supports matching on ESP. It doesn't. So let's say the following in here: IP access list extended ACL for ESP traffic. Permit ESP traffic, which is the control plane of the tunnel, from host router 2. So traffic is this sourced from router 2's gig01 interface 136.138.2, descent to router 1's gig01 interface 136.131.1. So from 136.138.2 to host 136.1.31.1. And then I match that into a class map of type inspect, which is going to be CMap of ESP. And I say in there match address access group name and the name of my ACL. And then I go under my policy map and say for the class map of type inspect, where I'm matching on ESP traffic, I want to pass it as well. I want to make sure that inbound ESP from router 2 to router 1 is being allowed. This is going to allow also the data plane traffic to work to the IPsec tunnel. And there we go, OSPF also worked. Now going on router 2, I should be able to ping router 1 at the tunnel level. And there we go. Okay, so I have built the internet to self zone policy, the internet to self zone firewall policy, internet to self. Well, initially I wanted to pass only SSH traffic from the internet. But then because this is an IPsec tunnel destined, which is sourced on gig01 interface, which belongs to the internet zone. So as router 2 sends the tunnel negotiation to 1, traffic goes internet to self. So I had to pass IKE. Then the control plane of the tunnel came up, but as router 2 was sending traffic in the tunnel to bring up the USPF neighborship, that was a ESP packet from router 2 to router 1 gig01. So I had to pass ESP as well. Okay, so this looks to be okay. Let's do the following. I have not configured any kind of firewall policies from the self zone to the internet yet. Let's make sure before we do that, let's make sure that SSH works from the internet to router 1 and list that. Let's make sure that SSH works. Let's see if router 1 has SSH enabled. Show SSH. Show IP SSH. It is enabled. Show run include username. Let's see if what is the local username. SSH is not enabled. It's enabled. username Cisco, password Cisco, and crypto key generate RSA, general keys, modulus 124, let's say. Label SSH. And then line VTI 04, login local to force local username and password authentication. And now let's go on router 3 and SSH to router 1. So traffic from the internet zone to the self zone of router 1. SSH -L Cisco 136.1.31.1 Cisco. And I got connected. Now before we move on, I want you again to understand exactly what I did so far. So we have the internet to self zone configured. Internet to self zone. Or I'm passing SSH. I'm passing IKE. And I'm passing, so not inspecting statefully, ESP. So as, let's take it one by one, SSH. As I send an SSH session from the internet to the self zone, then why is the return session allowed, which is from the self zone to the internet? Or when I send an IKE packet from router 2 to router 1, so from the internet to the self zone, why is the return packet allowed? Because also 1 has to send an IKE packet to router 2, so from self to the internet. Likewise, when I send an ESP packet from router 2 to router 1, internet to self zone, why is the ESP return packet allowed to come in, which is self to internet zone? Because as I stated, by default, there is a pass action from all zones to the internet zone, from all zones to the self zone, and from the self zone to all zones. Which means this is what I have configured for the internet to self, but I have the default settings for self to internet, which says pass any or all. That's why traffic works. I have not configured any policies from self to the internet, which means it's a pass any. So that's why it works. But based on this config in here, if I go on router 1 and try to now telnet out to router 3, that's going to be traffic from the self zone to the internet zone. It's going to match on the pass any action. But because it's a pass and not statefully inspected, as traffic flows back in, it's going to be traffic from the internet zone to the self zone. And return traffic is now going to match on my configuration. It's going to match on a class default. So now I lost. Now I cannot send pretty much any kind of traffic from the self zone out on the internet, because as it goes out, it's being allowed, not statefully, but as it comes back in, it's going to hit my configured internet to self firewall policy, which doesn't allow the return of telnet traffic. Let's confirm that. If we go on router 1, I should not be able to telnet router 3. There we go. Because return traffic matches on the class default, as expected. Because in my internet to self zone policy, I pass only SSH, IKE, ESP, but not a return of a telnet. And before I give you actually exactly what you should do in general, let's let this session to time out. Now show IP AIGRP neighbors. I have an AIGRP neighbor with router 3, which seems to be working. So this is an AIGRP traffic, which is a bidirectional session between router 1 and router 3. Which means traffic flows both from the self zone out to the internet zone as EIGRP, and also from the internet zone to the self zone, likewise as EIGRP. So it seems to work. Now, from the self zone to the internet zone should be allowed because self to internet I have no firewall policy configured. So I'm actually on that default pass any. But on the other direction, on the internet to self zone, I'm not allowing EIGRP traffic. I'm allowing only SSH, IKE, and ESP. So why does it work? Because it was pre-established. Let's say clear IP EIGRP neighbors, and it's not going to come up. And I already see that it says unknown layer 4 session, that's EIGRP, from router 3 to router 1. It's unicast traffic, as you can see. If you say show IP EIGRP neighbors, Q count is 1, and that's bad. To keep it simple, this is how, I'm not going to say what is the problem with the Q count, but you see that EIGRP does not come up. Now you might state that, okay, so EIGRP runs in multicast mode, and I stated that zone-based policy firewall cannot inspect or cannot affect multicast traffic. Of course. But any IGP, even if it runs in multicast mode, in that negotiation process at some point is going to turn over to unicast mode. Because this is what I see in here. That it's a EIGRP traffic, EIGRP traffic, it's unknown because it doesn't have the protocol. From router 3 unicast IP address to router 1 unicast IP address. So it doesn't work because it's very simple. Again, from self zone to internet zone, EIGRP is allowed because of the default pass any. But from the internet zone to the self zone, EIGRP unicast, of course, is blocked based on my policy. So I actually have to go in here and also make sure I allow the IGP to work from internet to the self zone. And I'm not sure if I can say class map. Probably I cannot. Class map, CMAP, EIGRP. Probably it's not doesn't support mesh protocol EIGRP. If it would, or it seems to be to support that. Class map, EIGRP, matching the protocol. And let's go under my policy map of internet to self. Let's attach that class map of EIGRP and say pass. Class map, of course, type inspect and say pass. Do show run policy map. Let's see why it didn't work. So self zone and pass. And let's say class map, type inspect. It may not be supported mesh protocol EIGRP. Yes, let's do so. It does support this, but not for the self zone. Let's reconfigure the class map to match an EIGRP by using an access. Let's do show run class map. So let's get it for the moment. No class map that. And let's build an ACL which says IP access list. IP access list extended ACL EIGRP. I'm just gonna not be specific this time to move on. Permit EIGRP any. And out of this class map of CMAP EIGRP, match access group name ACL EIGRP. And then I should be able to bind that class map under my policy map and pass EIGRP. Let's go under my policy map, self to internet to self, and let's put that in there. Well, yes, the problem is that I didn't configure the proper type of policy map. That was the problem. Let's reconfigure it. No class map, CMap EIGRP. So I configured the class map to be a regular one, not the type inspect. The message was pretty much self-explanatory. And then let's go my policy map and finally state that pass EIGRP. And then EIGRP should come up and be stable. There were Q count 0, now it's stable. So sharp route EIGRP, I should learn the routes again. And there we go. So you see, it's a good thing to control traffic, destined to the cell zone from the untrusted source. But it's very dangerous if you don't keep in mind the fact that by default it's a pass both ways. And you have to make sure that you allow from the internet to the self zone what it has to work, IKE, EIGRP, or BGP, or whatever you want. And then from self to internet, everything is allowed by default. Now, ideally, what I would do in a production network is that if I want from this router to be able to generate any kind of outbound traffic, like TCP or UDP, like a BGP session or a TFTP session, whatever, I would build a firewall policy from self to the internet and say inspect for what I want to allow, inspect. And then a policy from the internet to the self zone. And likewise inspect what I need to allow in that direction. For a simple reason, this is what I recommend you to do. Do inspect actions from self to internet, from internet to self. And then traffic which cannot be inspected, like EIGRP traffic, the IGP, or ESP traffic, you're gonna pass it in both ways. So you're gonna also say self to internet pass ESP, and also internet to self pass ESP. So whatever has to work and is not supported by inspection, you're gonna pass it. Okay. There's another question from Matthew. Is it like inside to outside on ASA, a higher security level to lower? Matthew, I'm not sure what I was speaking about in there, because first of all, in here we're speaking about traffic destined to the router or initiated by the router, which affects the self zone. Traffic inside, outside, or low to high, high to low on the SA has to do with transit traffic, not traffic destined to the ASA. So I'm not sure what you mean by that statement, that is it like inside to outside on ASA, a high to low. It is very simple. As long as you remember that by default, traffic from self zone to any other zone has a pass action, and all of it's passed. And traffic from any zone to the self zone has a pass action. So it's allowed by default and not inspected. As long as you remember those two golden rules, which is actually one, but it's different direction, then if you want to build firewall policies destined to the self zone or source from the self zone, you're going to be able to make it work easily. So I don't see, Matthew, how self to another zone or another zone to self is like inside outside on the SA. Oh, I see what you mean. You're just saying that because the SA by default allows inside to outside or high to low, pretty much you could assume that it's the same thing. Well, from a certain point of view, yes, because traffic works. So traffic from the self zone to any zone and from any zone to the self zone works. Likewise, as inside to outside or high to low, traffic works on the SA. So from the point of view that traffic works, yes, it's the same thing. But otherwise, it's two different. It's a totally different, let's say, fish. Because first of all, traffic high to low on the SA has to do with transit traffic, not destined to the SA. And here on the iOS, we speak about traffic destined to the router, not transiting the router. And second of all, as traffic goes inside, outside on the SA is being inspected, is being tracked in a state table, while on the iOS firewall, traffic destined to the self zone or source from the self zone is uninspected, it's passed. It doesn't keep track of the session state. So it's actually more different than, let's say, more similar. So it's similar only from the point of view that traffic works, both high to low on the SA and self to any to self on the iOS. From that point of view, it's similar. But otherwise, it's totally different in the end. And I hope that makes sense.